Hello everyone, welcome to the course Manufacturing Processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So, first we will discuss overview of today's presentation. So, last class, if you remember, we have already discussed what will be the shape and size of the riser. Also, we discussed what should be the optimum size for the top riser and what should be the optimum size for the side riser. We also derived relation for this. Today, we are going to discuss another method, that is modulus method of riser design. So, we will see in this method how to design the riser. So, we will start. So, what is the modulus method of riser design? So, we already know the basic principle of riser design is the solidification time for riser. If I am writing this one TR, this should be greater than equal to solidification time for casting. We know the formula for solidification time. This is nothing but volume upon surface area and a square of this one with a constant which is totally dependent upon the material that we are going to cast. So, this should be greater than equal to volume upon surface area of the casting. This is for riser times this gamma. This is a constant we know which is completely dependent upon the material that we are going to cast. So, we know that as material is same, either it is in casting or is in riser. So, gamma for both will be same. So, it will be cancelled out. So, what finally it will be? It will be volume upon surface area, a square of this one. For riser, this should be greater than equal to volume upon surface area of the casting and a square of this one. So, we have already seen in previous slides and last two sections that this is the basic requirement for a riser design. Means the solidification time for the riser should be greater than equal to the solidification time of the casting. Okay. Now, a new term, that is modulus, is defined as volume upon surface area. So, this volume upon surface area is known as modulus. Modulus. This is defined as modulus. So, that is why the name is modulus method of riser design. Okay. So, we already know if you write this in terms of this modulus and if you represent this by capital M. So, we can write this MR should be greater than equal to MC. That means, in terms of modulus we can write then this MR should be greater than equal to MC. Now, the question will come, how much it should be greater, what should be the value? This is already know, we know from this one, although we are using modulus here. From here also we know already that the solidification time for the riser should be more as compared to solidification time in the casting. But the question is, if we are using this modulus method, how much it should be greater? So, that quantitative data we need. So, experimentally it has been found that this MR should be greater than equal to 1.2 times, means around 20 times, 20% of this solidification, modulus of the casting. This is the experimental data. Experimentally it has been found that this modulus value for the riser should be greater than equal to approximately 1.2 of the modulus of the casting. So, this is what is known as modulus method of riser design. So, many numericals may be asked based on this modulus method of riser design. Today, I have brought one numerical which was asked in 2016 in GATE exam. I have brought this numerical just to make this concept that we have just now discussed, this modulus method of riser design, to make it more clear. So, we will take that numerical. So, this is the numerical. It was actually asked in GATE 2016. GATE 2016. Okay. So, what this numerical says, a cylindrical job of 200 mm diameter, a cylindrical job. Suppose this is a cylinder. This is cylinder of 200 diameter. So, this is given 200 mm. Diameter is 200, okay, and height of 100 mm. This height has been given 100 mm. Is to be cast using modulus method of riser design. Okay, assuming that the bottom surface of the riser does not contribute as cooling surface. Okay, if the diameter of the riser is equal to the height of the riser, then find the height of the riser. So, what has been given, that assume that bottom of the surface. So, suppose this is the cylindrical riser also, and what has been given, this bottom is insulated. The meaning of insulated is there will be no heat dissipation or there will be no heat transfer from this area. Okay, so this is insulated. Okay, another thing what has been given, that if the diameter of the riser is equal to height, so if we are taking this as height, that is a small h, and if we are taking this diameter a small d, so in the numerical it has been given d is equal to h. And if you remember, in last lecture already we have discussed, if diameter and height of a riser is same, it is a top riser, sorry, it is a side riser, okay, side riser. So actually this numerical is based on side riser, and we have to solve this numerical by using modulus method of riser design. So what we have to find out, then find the height of the riser. We have to find out the height. So we have to find out what will be the value of height. Okay, so we'll solve this numerical with this method. We'll apply the same formula that we just now discussed. This one, this is very important formula. So what we will do, we will equate this to MR. This is equal to 1.2, around 20% of this MC. So this MR we can write V upon C. This is volume upon surface area. Sorry, V upon S, surface area. What we are denoting by this? Sorry, V by A. Surface area V by A of riser, this would be equal to 1.2, that is more than 20 times of this MC, means volume upon surface area of casting. If we will write the value, so what we can write, actually this MR is equal to MC, and this is 1.2 times. So MR, as I told, this is volume upon surface area of the riser. This is equal to 1.2 times volume upon surface area of the casting. So this volume we can write, we know cylinder volume pi by 4 d square into h, and we can write this surface area of a riser. Only one cylindrical part is, sorry, only one circular part is actually free for heat dissipation. So we can write pi upon 4 d square plus area of the curved part, that is pi ds, and this will be equal to 1.2 times, and this is volume, so pi upon 4, and diameter of the casting is given, that is 200, into height is given, this is 100, upon we can write pi upon 4 200 diameter square times 2 times, because both circular section, and plus the area of the curved part, that is pi d is 200 into 100. Okay, so this is actually for casting. So as this is a side riser, so we can, what we will do, where d and h we can equate. So what will happen, if we will put either d is equal to h or h is equal to d, so this equation will have only one unknown. So what we will do, we will put d is equal to h, because we have to find out h. So this expression we can write simply, this pi by 4 will be cancelled out, and we are writing d is equal to h. So this is h square, it will be h square into h, so it will be h cube upon this one will be h square plus pi, and this will be h square, and this will be equal to 1 upon 2 pi upon 4, this is 200 square into 100 upon, this will be pi upon 4 200 square into 2 plus this will be pi, and this d is 200 into 100. So this is the value. Once we will solve this one, I am not solving, you can solve this, it's not a tough thing, easy calculation. Once we will solve, because why I am telling easy, because this is a linear equation and only one variable is there, that is h. So that h we have to find out. Once we will solve this one, we will get the value of h will comes out 150 mm. So this is the answer for this one. So what we learned from this, that today we saw what is the method of riser design by using modulus method, and we solve this numerical based on that. I hope everybody got this. We'll meet again in a next lecture. Okay, thank you.